So, dear students, this is Venkatachalapathi, Institute of Aeronautical Engineering. I would like to discuss on laser beam welding. What is meant by a laser beam welding in a manufacturing process? So, in general, the course manufacturing process for the fourth semester mechanical engineering students, we have studied in that course manufacturing process. There are 5 units are there. The first unit is the metal casting process, and the second unit is the fabrication process, that is called welding process. You know, the term welding can be defined as it is the process of joining to similar metals or dissimilar metals by adding filler metal, without adding filler metal, by application of pressure and temperature, without application of pressure and temperature. In that we have studied different classification of welding process, that is fusion welding process, pressure welding process, advanced welding process. Now let us see the advanced welding process, laser beam welding. So now I am going to discuss clearly what are the basic concept of laser beam welding and what are the principle behind in laser beam welding, and what are the advantages of laser beam welding, what are the limitations of laser beam welding, and how the application of laser welding in the present technical field and construction field and medical field, etc. We will discuss in detail about this later laser beam welding. Okay, now let us see what is laser welding. So you can clearly understand the diagrammatic representation, how the laser, as you know that the term laser or acronym laser stands for light amplification by stimulated emission of radiation. Look at here, this term laser stands for light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. But generally lasers work as a result of resonant effects. The main output of this laser is a coherent electromagnetic field, EMF, takes place in a coherent beam of electromagnetic theory or energy. All the waves have the same frequency and phase. So this laser beam welding also similar to electron beam welding. Only thing is they have certain the effect of this laser light amplification by stimulated emission of radiation will act effectively. So here that laser beam is the one of the main criteria how the laser beam will act on this. You can see the clearly. And as you know that laser beam welding is a welding process or welding technique and used to join 2 pieces of metal or thermoplastics. So in general some thermoplastics and thermosetting plastics also widely used to join this laser welding. So because with the use of laser. So here this laser beam provides a concentrated heat source. That is what here, the concentrated heat source, which allowing for a narrow or deep welds or high welding rates. So the process is frequently used in high volume and precision requiring applications using automation. So majority in automated applications, this laser welding are widely used, and especially these automotive and aeronautical industries, this laser welding process can be widely used, and this is the very keyhole or penetration mold welding can be done by this laser welding process. Okay, now let us see, we will discuss one by one the operation of laser welding and what is the principle behind of this laser welding. We will discuss in detail. The first point, you can see the operation of laser welding means just it is a similar to EBM, that is electron beam welding process. EBW, it is almost similar to electron beam welding. The only thing is in a laser beam welding has a high power density. So both are same, but only thing is a laser beam welding has a high power density which is in the order of 1 megawatts per centimeter square. Okay, and which will result in a small HAZ, heat affected zone, HAZ, where high heating and cooling rates can be occurs. Okay, and another important point of the operation of the laser welding is the spot size. Here you can see there will be a laser beam in a violet color, okay, or sky blue color. So there will be tungsten electrode with an inclination of 45 degrees, and the laser column, the beam comes from the laser column, and here this arc plasma 1.5 meter cube per hour, that helium, and here this is the workpiece 1 and workpiece 2. So these two pieces can be joined with the laser beam, okay, and the laser beam connected with this electrode, tungsten electrode, the voltage approximately 22 volts, okay. So that is also called the GTAW, gas tungsten arc welding. So gas tungsten inert gas arc welding process, where the voltage is nominal, that is 22 volts, can be widely used, okay. So this is what here, this is spot, okay. So the spot size of the laser can vary 0.2 to 13 mm. So this is very interesting. You can able to remember clearly that spot size will be vary 0.2 mm. This is 0.2 mm to 13 mm also it can vary, but thin to thick sections, and through only small sizes are used for welding process, and the depth of penetration is directly proportional to the amount of power supplied, okay. So depth of penetration, which is almost all directly proportional to the amount of power supplied, directly proportional to the amount of power supplied, okay, amount of power supplied, okay. And but it is also depend on the location of the focal point. So this is the very focal point where the laser beam will fell on that, so that due to that high temperature, high velocity, it can be joined together. That penetration which is maximized when the focal point is slightly below the surface of the workpiece. So the penetration is maximized when the focal point is slightly below the surface of the workpiece. This is what about the laser welding process, okay. Now let us see what is the main principle involved in laser welding. So it is a continuous or pulsed laser beam which may be used depending upon the application. So this is a continuous laser beam can be used depending upon the application. So where it can be used, what type of application, what type of material, and how we can able to perform. So this is another important, millisecond long pulses are used to weld very thin sections. Whenever this weld thin material such as razor blades, you can see the shaving razor blades, while continuous laser systems are employed for deep welds, okay. So this is the one important point in a principle of laser welding process. And another thing is laser beam welding is a verticile process, okay. It is a verticile. Why it is a verticile process? Any type of cross section, any type of material can be easily done by this laser beam, okay. So whenever, most probably the medical applications, this can be widely used. Even laser treatment also, you can see either tooth or nerves or any bones and all, the laser treatment will be costlier, but even though that will be most effective, the usage of the medical applications, okay. Especially the materials which is most probably carbon steels, HSLA steel, stainless steels, aluminum, titanium, these things are the most widely used in laser welding process. And due to high cooling rate, what will happen? Due to high cooling rate, the cracking is a concern when welding high carbon steels. So whenever due to laser, high beam of laser, what will happen? It will be heated, and due to that some cooling can be taken place. During that, suddenly if you do more cooling, the cracking, there is a defect, the cracking may be occur in a high carbon steels, okay. And another important point is weld quality is very high, especially if you perform a laser welding process. After seeing that workpiece, just like a mirror like surface finish, high quality weld can be obtained in this process. Okay, and it is also similar to the whatever the EBM process, so the same process will be done. Only thing is here a laser beam can be used instead of electron beam. And here also the speed of welding is directly proportional to the amount of power supplied. That's I have explained earlier. And whatever the speed means velocity, okay, n, which is directly proportional to the power supplied. So, but it depends upon the type and the thickness of the workpiece. Whenever the thickness is increased, the more speed of the welding can be done. And one more thing is here sometimes the gas lasers are very important. So the high power capability of gas lasers, which will make use of the especially suitable to high volume applications. So per shift, more number of components can be easily done by this laser welding machines. And another thing is LBW, laser beam welding, is a particularly dominant in the automobile industry or automotive industry. So why? Because even nowadays all e-vehicles is going to be come to the market and industry also. In automotive industry, not only four-wheelers, even autos and some complicated shapes also, there will be a typical laser welding machine can be used. You can see how the laser welding machine, where the spark will be joined very smoothly with the high velocity. The flow can be done very effectively in this small opening. Okay, so this is what about the basic fundamental principle of laser welding process. Now look at what are the good applications of laser welding. So in all the manufacturing process, especially for welding process, there are so many applications can be used, especially in the laser welding process. In a laser welding process is most widely used in a heavy industrial settings. So heavy industrial, that is electronic, automobile, food processing, these all comes under the laser beam welding process. And some of the parts like industrial oven doors and drive gates, exhaust heat shield, stainless steel appliances such as what you call here, you can see the stainless steel appliance also can be used to do this laser welding process. And majorly you can see the list out some of the various applications of laser beam welding: electronic, automotive and food processing applications. This method is most widely used. And some of the spot welding. So you know that spot and seam welding. So when one spot is there, that is spot welding. So there will be one workpiece and another workpiece. Here you have to touch. This spot is called spot welding. The spot can be varied by series of spots. That is called seam welding. Okay. So like that, here you can see the spot welds can be easily made by laser welding process. And some of the components are welded easily for vacuum. Vacuum components can be easily welded. And some medical equipment, most probably whenever you feel discomfort in the knee pains and hand pains and some of the what you call laser treatment of the skins and some dental problems and all, this laser treatment can be supposed to be used to get good application. And coming to the carbon steels and ferrous materials are also welded through this laser beam welding process. And it is also used to weld IC integral circuits to some plates. IC2 plates also can be widely used in this laser beam welding. And in any aircraft industry, say the Boeing 747, aircraft, so these to weld so many light gauge materials such as copper, nickel, aluminum and titanium, zirconium, tantalum, collinium. These all materials can be usually done by this laser beam welding process. And another thing is wire to wire and sheet to sheet, tube to sheet and small diameter struts. So this is also another interesting application. So some wire to wire, sheet to sheet, pipe to pipe, tube to pipe and sheet. So any type of diameter and can be fabricated using laser beam welding process. Now let us see the after understanding the applications. Now what is the special use of laser welding? So this is very interesting. The diagrammatic representation, you can see the scanning direction, how it will move from the left to right. Okay, the first and foremost thing is laser radiation head. We can also call the laser radiation head, where they can provide some of the laser material. Okay, and the second point is that yellow in color is a laser light, light amplification simulated. So this is what acronym of laser means: light amplification by stimulated emission of radiation. By stimulated radiation of stimulated emission of radiation in a laser. That principle involved in effectively. And look at this can be done by lap joint. Even when you are discussing some ferrous metal or non-ferrous or thermoplastics, all these materials can be do it for scanning direction. Then once you know the scanning, what type of material to be selected, what will be the aspect ratio, that is large depth to narrow depth, okay, D by W ratio, and this laser welding therefore is feasibly for joining configurations such as many other welding techniques, okay, such as this what you call stake welding through lap joints, okay. And the third important point is where the molten layer, this is called molten layer. Fourth one is transmission side material, laser welding compatible guide should be preferable, and a laser radiation head. The fifth one is again a radiation, what you call sixth one is radiation head, and laser light is in 7. These are called some yellow color laser light, okay. Laser light is a very important one, and so that laser welding components where the grade, different type of grades also can be used, and even laser radiation head, laser light, and molten layer also one of the most important parameters while performing the lap joint. So the one plate over the other is called the lap joint. So that how do you perform some laser welding through easily processed in examination, okay. So this is what about the special use of laser welding. So these mainly the metals such as thermoplastic metals, and even being such a concentrated heat source in the thin materials, laser beam can be carry out the high welding speeds of meters per second, meter per second, and in thicker materials can produce narrow and deep welds between the square edged parts, okay. And what I wanted to explain, this laser welding allows welds to be made without aspect ratio, without high aspect ratio, and there will be a conduction takes place, conduction and radiation. In the conduction, welding techniques such as stake welding through lap joints can be widely used in the case of special use of laser welding, okay. So this is what about the how we can able to explain with the diagrammatic representation of lap joint with the multiple objectives, okay. Now look at the what are the various metallurgical properties of laser beam welding. So in this look at this Ishikawa diagram. Ishikawa diagram or vital few trivial meaning. It is a cause and effect diagram. Cause and effect diagram. So this cause and effect diagram, so which is the most widely used in the metallurgical properties distribution curve, okay. And in this case the first and foremost point is the material, how we can able to control the material. So these are the material causes, and rectification is thickness, surface reflectivity, and thermophysical properties are the one of the most interesting, and to improve the material properties effectively. And laser beam, so where you can see the pulse shape and energy and pulse repetition, what you call the repetition rate and pulse duration. Okay, so all these very interesting one. All these what you call the elliptical shape, material, and some case displacement, some shielding glass, focusing lens, laser beam, and quality weld. Finally, to achieve good quality weld, you should be able to follow the causes and remedies of the this Ishikawa diagram or fishbone diagram. This is also called the fishbone diagram. Okay, and what are the various causes which will influence on the material? Is the first thing is thermophysical properties, surface reflexivity, and thickness. These three are the very important one, so that they can improve the material properties. And laser beam mainly average power and beam defense, divergence, and what you call intensity distribution, and some pulse shape and pulse energy and pulse repetition. Pulse duration is the one of the most widely used in this laser beam. In order to operate in a good beam type, we should use the all pulse shape, energy, and repetition and duration. Well, coming to the other side, obviously average power, beam divergence, institutionally what you call intensity distribution, also very important, and shielding gas is so there are various causes which will influence the this shielding gas, especially the shielding gas, mainly nozzle design, position and direction of the nozzle, and what you call this type of gas and the flow rate of the gas is very important, and to adjust that the shielding gas can be done effectively. And even focusing, this focusing in the sense, this is what this yellow color, and another focusing, this is also laser beam with the focus work. Okay, so that is what this metallurgical properties of laser beam welding. So look at step by step procedure. Laser beam welding has become one of the most welding techniques where or which the modern industries became its superior what you call stadiums, and such as high welding speed, also very important. High welding speed and thermal distortion, and the ease of automation, thin and what you call strong weld seams. One star is there. It is what you call spot welding, and continuous stars is there. It is what you called continuous star, where you can see the weld quality. Okay, and some of the electrodes such as neodymium, YAG, and CO2 lasers are being widely used in the industries. So this is what about metallurgical properties of the distribution curve, where you can able to understand. The final intention is to improve the weld quality, weld quality, and whereas the other parameters like material, displacement, shielding gas, focusing, and what you call other thing is flow rate or flow gases. These all under comes under the as per the inspection concern. Okay. Now let us see what are the basic advantages of laser beam welding. So this is the step by step procedure. So for working of a laser beam welding process, the first step we can see the overall lay, transmitting material and absorbing material. Okay, the first and foremost point is gray overlap, transmitting the material and absorbing the material. The second figure shows that irradiate the laser from transmission material, and where light is converted into heat, and the boundary stuff causing to melt. And the third important point is transmitting material is also melted due to thermal conduction from melted of the absorbing material. And last but not least, the materials cool and solidify to form a bond. So you should able to cool and solidify the bond so that it will get effectively. Okay, and this is what interesting one. And coming to these limitations, what is the main limitations of laser beam welding? So there are some nearly 8, okay, 6 to 8 limitations are available. The first point is the welding equipment. What do you call welding equipment is expensive, and so that cost of this process will be very very high. Okay, especially why always you can prefer the some different type of roadside welding process and all, how they will perform, how they can able to do effectively, you can able to understand and discuss. Okay, and the second point is if the filler metal is necessary, but in this process limited uh, filler metal is relatively expensive, and there are a few postdoctorate students. Okay, there are few post welding operations, and this is very costly for the patients. Why? Because laser beam, any simple treatment also it is very costly, and you need to support to understand clearly. Okay, and consequently more consumption of the patients required laser based machines. Okay, laser based machines, and it is a costly for what you call patients and specialists, even intricacy and dental method and high forces in a cutting cycle. Okay, so that is why these are the some following disadvantages or limitations of laser beam welding. The welding equipment is expensive, so that the cost of this process is very very high, and at the same time the filler material is necessary, but this process is limited to the produce with the use of filler material, so relatively expensive. And another important one, there are a few post welding operations, and this costly for specialists also, not only for patients. Some costly for the specialist, and less uses in dental method. Here in this college, less uses in dental method, and high surface during metal cutting cycle. Okay, so these are the some important limitations of the laser beam welding. Okay, now look at these are the applications. So why you have to do the application? So in this case, Volkswagen car in laser beam welding, and how they can perform the laser welding robot. So because more temperature, more concentration is difficult to what you called hardened, and surface modification can be done. So the lasers are widely used for laser material processing in manufacturing. For example, this is a cutting process, drilling process, welding process, cladding process, soldering, hardening, and marking, engraving the forthcoming pulse layer positions, lithography. Okay, so this is what about the some little bit applications of laser beam welding. In the, this is what Volkswagen laser beam welding, where it can assess the some of the parameters like the suspension system, exhaust system, component system, electronic interior, passenger safety, and the chassis, engine. Okay, and this Volkswagen car in a laser beam welding, how they can perform, how they can able to understand the applications of laser beam welding, especially this laser beam welding can be able to do some of the cladding, soldering or brazing, hardening, surface modification and marking, and some micro mission pulsar laser depositions also will be considered. And finally lithography is the one most important. Okay, this is what about the some laser beam welding process. The student you can supposed to understand clearly what is the usage of this laser beam welding. So that is what the light amplification by stimulated emission of radiation. Okay, so now this is the operation of laser beam welding, where you can able to continue it. And this is another principle, that is speed is directly proportional to the what you call power intensity. Okay. And coming to these applications, most probably electronic, automobile, and food processing industry, and vacuum components also served very easily. Okay, and medical equipment and carbon steel are most probably the ferrous metals are can be used, and where you can use the weld IC to some plates. Okay, and some copper, nickel, aluminum, cesium, and titanium, zirconium, tantalum, curriculum, etc. What are why sheeting to sheet, tube to sheet, and small diameter to long stuff welds. Okay, so this is what about the application of welding. Okay, and coming to this laser welding in a lab joints also, this the number stands for laser radiation head, laser light, modern molten layer in the, this is the third important molten layer, and laser welding compatible what you call grade. So absorbing side material absorbs laser light. So where you can use the radiation head. Okay, laser method, and which will have some molten layer. Okay, and this is what the cause and effect diagram for performing metallurgical applications of distribution curve. So this based on the cause, the effect will be identified. So for example, material have a proper thickness. Okay, otherwise you can reduce the thickness, and surface reflectivity and thermophysical properties like that, laser beam and focusing, shield gas, shield gas also, nozzle design, and other gas flow rate can be suitably understood. Okay, and finally, weld quality is very smooth. Okay, so this is how the overlapping of transmitting the and material and absorbing the material. And the second point is it irritates the laser from transmitting material side. The laser light is counted into heat source at the boundary, the surface of the absorbing material causing melting. Okay, so third point is the transmitting material to a method due to thermal conduction and selection a melted section of the observing material. And finally, the materials cool and solidify to form the bond. And these are some of the limitations of the laser beam welding, where these are the medicines, these are additive, expensive laser products. And the laser welding robot. So even the fabrication, assembling of 2 or 4 wheelers, cars, okay, and they can perform effectively how they can do the fabrication in a Volkswagen car and Volkswagen car in laser beam welding is it's a powertrain, it has engine, it has a chassis and passenger safety. That's what you call charges safety, and what you called inferior. So there is interior decoration, electronic and components, exhaust systems and suspension. These are all the parameters were efficiently required to complete that inspection. Okay, and apart from that, this is what I hope the students can understand clearly. And this is what about the main principle, advantages, limitations, and applications of laser beam welding. Okay, thank you, good luck.
Like, share, and subscribe. Hit the bell icon for more updates.